Hi everyone. Just want to take some time to go over the math video for this week. It's basically we're going to be talking about is going to be multiplying and dividing rational expressions. Okay. So if you want to mention this, a rational expression is basically this. It's an expression on top of the expression. So basically this expression x plus 3. Oh, sorry about that. Let me hide this real quick. Oh. So basically x plus 3 over x minus 2. And this is basically a rational expression because of the fact is x plus 3 is divided by x plus 2. So the idea is one thing you want to talk about is we're going to basically be simplifying these expressions, and then we're also going to be trying to find excluded values, or they're also called extraneous solutions. Okay? All right, but I don't mind you just using the word excluded values. That'd be easier to do. Okay, so one thing you want to talk about is, I'll give you an example of this, is the no-nos, or the things you don't want to do when you're multiplying, dividing rational expressions. Okay, so first thing is, here's the expression, rational expression I'm going to give you, 4x plus 3 over 2x minus 9. Now I can't reduce anything or simplify any top or bottom, but if you're looking at it, you probably would see that 4x and 2x. I'm like, oh man, 4x and 4 divided by 2 is going to be 2. So I can basically reduce this to 2x, and I can reduce this to 1x. Okay, and if I look at this, I got 3 and 9. Those go into each other, so I can basically reduce this to 1 and this to 3. Unfortunately, you cannot do that. This is wrong. Okay, and the reason why is because the fact is when you're reducing, you need to reduce identical expressions. Okay, you got to reduce identical expressions. So basically, if you think about it, it has to be 4x plus 3 over 4x plus 3 to reduce this fraction. Okay, and that will reduce it. So make sure that you mention that it has to be identical expressions so you can reduce them. It doesn't matter if it's top or bottom, or if it's the other equation or what, you can reduce them if they're exactly the same. Okay. Now the first problem I'd show you. Okay. I'll do it right here. So the first problem I would show is this is more of a simpler problem, but it kind of gives the idea of how excluded values work. Okay. So basically, if you have 4x plus 3 over 3 and over x minus 4, x plus 3. Okay, so now the first thing is, okay, is how do we find the simplified version of this reduced this fraction? So we have two identical expressions on top of each other, x plus 3 and x plus 3. So these two would cancel each other. Then we're left with the 4 over x over 4. So that would be the reduced fraction. Now, again, I can't divide 4 divided by 4 here because these are two different expressions. This whole expression has to be exactly the same so I can reduce it. Okay, so this would be the simplified expression. All right. So the idea is, what is excluded values or extraneous solutions? They are basically solutions or x values that are that I'm sorry, not are that make the equation undefined. Okay, so that's how it works. You have to make the equation undefined. So in a fractional terms, okay, so this is the only way you can make an equation undefined. If the denominator equals 0. When the denominator equals 0 after it's solved, then that automatically tells us it's undefined. If you want to check that, put that in your calculator. Put 0 divided by 1. You can't divide 0 into 1. It doesn't make any sense. So that would automatically tell us it's undefined. Okay? So in this situation, that doesn't matter, man. It's all right. I'm on my speakerphone, so it doesn't matter. The dog's barking, so just let that. So the excluded values of this situation would be, so again, if I have x minus 4, If I set that equal to 0, I know 4 is going to be an excluded value. But also, if I look at this one, x plus 3, if I set that equal to 0, I know that's going to give me a value of negative 3. Okay, so 4 and negative 3 would be the excluded values in this situation. Okay, now you could check that by plugging those into the equation. Okay, so usually what happens is there's only one excluded value. Okay, not two. Okay, but as you can see here from the equation, if I plug these in, one of them is going to give me an answer. Either one is going to give the answer. But as you can see, actually, I'll make this easier. Just use the simple, to make this easier, let me check that back. Hold on a second. To make this easier for you guys, I know you guys will listen to that, but I'm just going to try to make this easier. Use this equation right here, and then set the numerator equal to 0. So x minus 4 would equal 0. Add 4 to both sides, and then you're going to get 4. So your excluded value in this situation would be just 4. Okay. All right, and any other value that you add in for x to solve this would give you an answer. So you're looking for a situation where you make the equation undefined. And I know that because if I plug in 4 for x, 4 minus 4 would equal 0, and 4 over 0 would give us an undefined answer. So that's how I would know that information, okay? So we're looking for extraneous solutions or unexcluded values, okay? And this is going to help you once we get into square roots and stuff, because we're going to do some algebraic work on square roots next week. And basically, we're going to be trying to find extraneous or excluded values in those things as well, because that's very important, okay? So again, those are 2 problems that you'll have to do, and then I'll have a 3rd problem for you guys. That's two actually more problems, so you'll have to do 4 problems for this video. Like I said, it probably takes you about 10 minutes to do the whole process, but I think it's good practice for people to see. So I'm going to go on to that right now. So, all right. So let's look at this here. So we have, let me give you an example. So we have an example. We have 2x squared minus 12x. Okay, and then we have x squared minus 2x minus 24. Okay, so we basically have 2 rational expressions. We have an expression on the top, expression on the bottom. We just have to simplify. Okay, so again, the first way I would use GCF, greatest common factor, and you can use that doing making a small box of 2. Okay, so 2x squared minus 12x. Okay, so that would be 2x on the side because that would be the common factor here. X on the bottom, and then you have negative 6. So that's going to work out to 2x, x minus 6. And then this one is, you have to use the box method because it is a quadratic. So if I make the box out, okay, x squared, negative 24, negative 24x squared, negative 24x squared. And then you got to figure out what 2 numbers multiply together to equal negative 24x. And add up, subtract to negative 2, which is 6x and 4x, which is negative 6 here. And then do the outside, x, negative 6, 4. So the new equation for that would be, so if I read it out, put all this back together, I have 2x, x minus 6 over x minus 6, x plus 4. Okay, so again, the rule is to reduce, you have to have identical expressions on top and bottom. So if you look at this one right here, boom, this is 1, this is 1. So my final equation would be x plus 4, 2x, x plus 4. Now, unfortunately, I can't reduce this any farther because this is a non-identical expression to the bottom. So I can't reduce this. So the idea is now, what's the excluded values? Okay, should be pretty easy if you think about it. Okay, because then you have x plus 4. So you just have to set that equal to 0. So the excluded value would be negative 4. Okay, because negative 4, plug that in. That's going to give us a value of 8, and negative 8 over 0, which is undefined. Okay, so you want to be able to mention that the excluded value would be negative 4 in this situation. Any other value of x that's plugged in will give you an answer, and that's what you're looking for. Okay, so that's number 1. That's a problem that you'll have to do. Okay. The second one, harder problem, is basically I'm going to give you two rational expressions multiplied together. I was going to give you a division one, but I think people kind of get that idea of change flip, so I'm not going to have to do that. But if you want me to do a question on that, I can do it. All right. Actually, why don't I just do this one and make this into a one like that? So we have k8 over 4k plus 20 divided by, let's go 10k squared plus 50k, and we have 5k. Okay. So the rule is when you have division of fractions, again, it's keep change. Oh, hold on. Oops, I did it wrong. It's not KFC, it's KCF. Keep change flip. So the idea is I'm going to keep this the same. I'm going to change this to multiplication in the middle. I'm going to flip the values. 5x over 10x squared plus 50x, 50k. Okay, so that's how we would do it. Now we need to simplify, reduce. So if you look at both bottom and top here, okay, I can do some work here. So I can reduce this can be reduced, and also this can be reduced. All right, so if I did this on the side, I just have to use the small box for the binomials, 4x, 20. Okay, and 4 is going to be the common factor. This is x and this is 5. And I can do the same thing for the bottom one. I have 10x squared 50x k. So then I could just factor out of 10k. This give me k and this give me 5. So again, if I move this along, my answer is k8 over 4x plus 5 times 5k over 10k k plus 5. Okay, so now looking at this value here, I can reduce the same thing. I can reduce this and reduce this. And looking at the bottoms here, I can also reduce both of these as well, because again, I have a 5k and I have a 10k. So this would cancel and this would cancel. This would be 1. This would be 2, because 5Ks and 10Ks, basically I have to multiply by 2 to get to 10, so that would reduce that. And also, they're outside of the parentheses, so they're actually their own expression. So if they're almost similar, but they're in the same common family. Okay, so they can definitely be reduced. Then you want to multiply across here. So then I'll have k plus 8. Okay, and then the last thing I'll have is 8. Okay, now I can't reduce the 8s and 8s because again, this is a whole expression. This is just by itself, so I can't reduce that. Now the idea is, what is the excluded values here? Okay, and now in this situation, I have just a whole number on the bottom. So there's no x plus 8 or anything on the bottom. So there's no, if I set it equal to 0, there's going to be no opportunities for me to find a number that I can exclude. So the excluded values is going to be none in this situation. Okay, so again, those are kind of the problems that you're going to be doing for this work here today. If you have any questions, please reach out to me and let me know. I'm going to try my best to answer them the quickest possible. And like I said, if you need to set up a Zoom call, just let me know and we can do that as well. All right. Talk to you later, guys. Good luck this week.